Central College chapter of ACS, and we're here today to show you the STEM demos that we bring to local schools and nonprofits to help close the education gap, as well as improve STEM literacy for those who are low income and minority students. Before we start, we need to make sure that we have proper lab safety, including lab goggles, lab gloves, closed-toed shoes, and, if you're feeling snazzy, lab coats. Hi, I'm McCall, and we're about to show you a demo we like to call the flame test. Before we get started, Ben's going to show you all the science behind it.
Hi, I'm Ben. I'm going to explain to you the science behind the flame test. So, in a moment, we're going to see some solutions over a Bunsen burner. These solutions have metal ions, which have their nucleus made of protons and neutrons, and the surrounding electron cloud. In this electron cloud, we have the electrons. The flame from the Bunsen burner adds energy, taking the electrons from the ground state, a very low energy stable state, into the excited state, a very high energy but very unstable state. Once the electrons go from this excited state back down into their ground state, energy is released in the form of colored light. So lithium will show a red color and copper will show a green color. So let's take a look.
Now that we've seen the science behind it, let's get started. Here we have 5 different metal ion solutions. The first one we're going to start with is lithium chloride, which, as you can see, creates a bright red flame. Next, we have potassium chloride, which has a beautiful violet hue. After that, we have copper sulfate, with a lime green flame. Now that we've completed the experiment, let's go over waste and safety protocols. First, turn off the gas to extinguish the flame. Next, look for any open containers and place the lid on. During the experiment, make sure to dispose of dowels in appropriate waste containers. For example, a beaker containing water. And that concludes the flame test. Thank you for watching, and we hope you learned something new.
Hi, for our next demo, we have the can crush. So, for starters, I'm going to take a soda can and fill it up with a little bit of water. Next, to heat up the water, we're going to use a Bunsen burner. So, under close adult supervision, we're going to start the gas and use a striker to light the Bunsen burner. Just a flame if needed. Now we're going to take a pair of crucible tongs and hold the can above the flame to allow the water to heat. We're going to wait until we can hear the water boiling and see vapor rise out of the opening of the can. What this indicates is that the air is being pushed out of the can. After that, we're going to place it into an ice bath, which is going to condense the water back into its liquid form. This will create a lack of air pressure within the can, which will allow the pressure on the outside, the air around us, to crush the can. Now that we have the water boiling at an adequate temperature, we're going to now take our ice bath and place the can into it and let it crush.